Greetings from Arizona. I'm Jim Phillips, and we're going to be talking about the changes to the 2021 edition of NFPA 70E. It's great to have all of you joining in. In fact, this is one of the largest live streaming groups that I've had in quite a while. It's really a privilege for me to be here in front of all of you. And in fact, we have people from 18 different countries that are logged in right now. 18 different countries today, or this evening, or tomorrow. Guess it depends on where you are with those 18 countries in relative to planet Earth. So before we begin, I have some things that I need to discuss here, and that is the views here. This material. These are my views. This is coming from me personally, because I'm involved in a lot of standards, as many of you know. I'm vice chair of IEEE 1584 and the international chair of the IEC Live Working Standards. And I'm on the NFPA 70E committee and some other committees. And so I'm actually obligated or required to state that these views are mine and may or may not represent any particular standards group or committee. So a lot has happened since 2018. From 2018 to 2021, what has happened to NFPA 70E? Well, a lot of things have happened. To begin with, for the revision cycle, there were 332 public inputs that were made. You may think of these as more like a proposal. In fact, that's what they used to be called years ago. That led to 86 first revisions. And then on the second cycle, the second draft, there were 115 public comments made, and that led to 43 second revisions. Now, what happens with each revision cycle of NFPA 70E, I know because I've heard this before, that some people think, oh, it's a group of people in this room and you're tweaking and refining and redeveloping. And not really. The revision cycle includes the input from everybody out there in the electrical world. And so the public inputs, those come from people like you. So actually, if you think about it, each revision cycle for NFPA 70E is done with the input of everybody out there in the electrical community. So with that, we're going to begin, and I have a very important question for you. What is the most important aspect of electrical safety? Now, you probably don't have to think about this too long because it's fairly obvious, and it's certainly one of the most important points within NFPA 70E. And so the answer to this question is, of course, it's electrical hazards, actually the elimination of electrical hazards. And this has always been first and foremost. Eliminate the hazard, and then you have an electrically safe work condition. And there's a whole process that you go through for this. With the electrically safe work condition, there have been a few changes, actually clarifications made, and I'm going to focus on this. And in fact, with NFPA 70E, the way I've always looked at the revision cycle is I look at it in terms of like themes. That's just a term that I use. In terms of themes, that every revision cycle, it seems like there are certain big, broad-reaching themes, and elevating the electrically safe work condition to an even higher level, that's one of the themes again for the 2021 edition. And also another theme is another reorganization, which we're going to see. There was quite a bit of reorganization again with the 2021 edition. We're going to begin by talking about definitions. And you might think, oh, come on, definitions really? Well, actually, yes, because definitions are very, very important. Let me explain why that is. So I've been involved on the legal side of things off and on for years, expert witness and things like that. And oftentimes that conversation will direct itself towards, well, what is the actual definition of that term? We're talking about this, but I have an interpretation, you have an interpretation. What's the actual definition? And so definitions really are a pretty important part of NFPA 70E. And with the 2021 edition, yes, there were some revisions and modifications, But some other things happened. Some of the definitions were actually just deleted from NFPA 70E. You may think, deleted? Why would you do that? Well, it's just terms weren't being used. And so there were actually some terms in the definitions that weren't being used, so they were just removed from NFPA 70E. And there were some definitions that were just changed to match the wording. It's in the National Electrical Code because we need to have some consistency in there. So you'll see some word changes that's just to align with, for example, the NEC. There's some other changes to clarify definitions a little better. And the first definition I want to begin with is just balaclava. Previously, the definition of balaclava included the word hood and the word sock. And so, for example, this one is mine. If you look at a balaclava, it's like, well, it's not really a hood, and I can't really say it's a sock. And so the definition was just changed to eliminate those two terms. And it's now just defined as an arc-rated head protective fabric that protects the neck and head except for a small portion of the facial area. And this is the complete definition right here. Definition of a barrier. There was a change made here, and this was to align with some other references within NFPA 70E. So, for example, in this case, the barrier, the last words, to prevent unauthorized access to a work area. That really wasn't what the barrier was all about. It's to prevent contact with equipment or energized electrical conductors. And so the definition for barrier now states that it's an obstruction intended to prevent contact with equipment or energized conductors and circuit parts. The electrically safe work condition. This is quite an important change. I talked about the theme, as I referred to it, and how the electrically safe work condition is this reoccurring theme, and it keeps getting elevated to a higher and higher level. And there was a kind of a significant clarification. I don't want to say it's a major change, but it's a clarification to the term electrically safe work condition. So this is the definition as we've had it, and it's a state in which an electrical conductor or circuit parts has been disconnected from energized parts, and we know the rest of this. But what has been clarified is the word condition, electrically safe work condition. So to introduce this, I thought, well, let me consult the dictionary of all places. Let's take a look at what the word condition means. It's a state of something. And that is exactly what the clarification was all about, that the electrically safe work condition, it's a state. It's not a procedure. Yes, there is a procedure, but that's later on in NFPA 70E. So because of this, there was an informational note added, and the informational note clarifies this by stating that an electrically safe work condition is not a procedure. It's the condition. It's a state wherein all hazardous electrical conductors or circuit parts to which a worker might be exposed, and you could read the rest of it. But this is all about just the actual state. Now, to establish the state, yes, there is a procedure for that we see later on in NFPA 70E. We also have the term arc-resistant switchgear being changed to arc-resistant equipment. And the reason for this, when this type of construction was first introduced years ago, it was switchgear. But over the years, there's been the introduction of arc-resistant motor control centers and other types of equipment. So it's time to move the focus away from just being switchgear and move it towards its arc-resistant equipment. And there was an informational note that was added this time around referencing the appropriate standard, IEEE C37.20.7, which is the guide for testing switchgear for internal arcing faults. And also, there's a reference to Annex O, which is for safety-related design requirements. Now, I want to give you kind of a heads up of what's coming down the road, and you actually may want to write this one down, that there has been a standard in development for quite a few years. I'm actually on that committee too. And the number that you want to write down, it's called IEEE 1814, IEEE 1814. It's not out yet. It's probably at least a year or two away. It's getting pretty close, but It's probably a year or two away. And that is going to be called the recommended practice for electrical system design techniques to improve electrical safety. And so that's going to be coming down the road, and that's going to have a lot of good guidance as far as basically designing safer electrical systems. Another change to a definition, the shock hazard. Now, this seems simple enough. It's a source for possible injury and damage to health, but the word exposed was added because it did say caused by contact or approach to energized electrical conductors. And so there's a clarification, exposed energized conductors. For example, if you have a switch, there's energized conductors in here, but they're not exposed. So it's not a shock hazard. Whereas if you open it up, you may be thinking, Jim, the switch is off. That's still not a hazard. Actually, it would be. I mean, of course, this isn't wired into anything. But if this was connected, there'd still be a hazard up here at the top terminals. So this was a bit of a clarification that it's not just energized conductors, it's exposed energized conductors. And part of this is there's actually a definition within NFPA 70E for the word exposed. And so this definition has already been there, and it's that it's for conductors and circuit parts capable of being inadvertently, that's a key word there, touched or approached nearer than a safe distance. And so this definition is there, and the word exposed has been added to the shock hazard. Nominal voltage. This is about DC voltage. It's understood that certain battery systems are actually rated 48 volts nominal, but they can have a float charge up to 58 volts. And so in DC applications, 60 volts is used just to cover the entire voltage range. So that was a new informational note. Article 110. Article 110 has had a massive overhaul, a big reorganization. And what happens is when you develop standards, and this goes through all the different standards, not just NFPA 70E, that as standards are developed, they evolve to where you have pieces all over the place. And so like there's a discussion about this over here, but also there's something over here. It's just how they evolve. And so every now and then you take a step back and it's like, no, we need to actually pull all these things into the same location. And so with Article 110, that's actually what happened. In fact, within NFPA 70E, I look at it, there's a lot of great material in there. But I look at NFPA 70E, the key articles are just Articles 110, 120, and 130. Yes, there's more beyond that. There's Chapter 2 and Chapter 3 and so forth. But those are the big three, 110, 120, and 130. And so 110 are for the general requirements. And there were some requirements in 120 for lockout, tagout, and the electrically safe work condition. And in 130 for working around the electrical hazards, there were actually, they belonged in 110, the general requirements. So as part of this reorganization, so to speak, what happened is we have the original sections that are on the left. We have 110.1 through 110.7, and that's what we had. Well, with the 2021 edition, we still have these same sections. But now they're from 110.5 up through 110.11. So they have different numbers. And so you may be thinking, oh, so what about 110.1 through 110.4? What's going to fill that space in? Well, it's information from other parts of 70E that have been relocated. For example, 110.1, the first section, the most important is priority, which I'm going to discuss. 110.2, general requirements, that came in from Article 120. 110.3, that moved in from Article 130. And you could see what happened here. So there were certain language and subsections from other parts of NFPA 70E that were better suited for Article 110. And then also down at the bottom, there's a new section in here. It's 110.12, and it's for equipment use. And we'll take a look at this. To begin with, I want to talk about priority. So priority, this was introduced in the 2018 edition of NFPA 70E. And again, I consulted my dictionary, and it said that priority It's a fact or condition of being regarded or treated as more important. And so this originated in section 105.4, and now it's been relocated to 110.1. So what is it about priority that is so important that it's going to be 110.1, the very first text that you're going to find in 110? Well, the priority. This goes back to the question that I asked you when we got started. What's the single most important aspect of electrical safety? Eliminating the hazard. And so because of that, this is the priority, the single most important priority throughout all this. Eliminate the hazard. So much so that it was moved to 110.1. The first thing that you're going to see. And there's also an informational note that references that hazard elimination is top on the hierarchy of risk control methods. It's at the top. And even NXF about risk assessment gives examples of hazard elimination. And elimination is number one for all of this. There was also an informational note that's new. Informational note number 2, discussing that the electrical safe work condition, again, it's a state. And it goes on to describe what that state is. But further down, it references Article 120 for the requirements to establish an electrically safe work condition. So really, we're looking at two different things. We're looking at the state of the electrically safe work condition, and then we're looking at what are the requirements to actually establish the electrically safe work condition. There's a new informational note, and this informational note references a job safety planning checklist. Really important. You might think a checklist. I mean, weren't people already doing that? Well, hopefully it's a good idea, but checklists are incredibly important. Now let me explain why checklists are so important. Years ago, I used to fly. I actually flew a Cessna 172, and when you're a pilot, you learn the importance of pre-flight checklists. Because it's better to be out there checking your flaps, your aileron, your carb heat, even though you're burning expensive aviation fuel and putting time on the engine. It's better to go through all that because you learn the importance of being able to catch a problem while the wheels are still touching the ground. Because once the wheels leave the ground, it's a whole different thing. Now you have to contend with the effects of gravity, and that could be a problem. And so the same kind of thing holds true when it comes to electrical safety. Checklists are very, very helpful because it's much better to go through the checklist and maybe catch a problem or realize you need to rethink something than to wait until there actually is trouble and you're trying to figure things out very quickly. So a checklist is a really great way to do this. So checklists are now an official part of this. 110.3, the electrically safe work conditions. Some of this information was relocated to 110. And it's not the procedure for establishing the electrically safe work condition, but it's information about the electrically safe work condition when it's required. And it's required if an employee is going to be working within the limited approach boundary and there are exposed parts, and if the employee interacts with the equipment where conductors or circuit parts are not exposed, but there's an increased likelihood of injury from an exposure to an arc flash hazard. So this second item, this was first introduced in 2009, the 2009 edition of NFPA 70E. And I remember when this was introduced because everybody just referred to it as one word, interaction. Like, what does that mean? And there was a lot of confusion. Like, is just operating a circuit breaker, is that interaction? Is that an arc flash hazard? And it wasn't really clearly defined. 2012 tried to clean it up a little bit. 2015 was the first time you started to see certain types of activities, operating a circuit breaker or a switch, doors closed or so forth. And then you also saw what is considered normal operation. And I'm going to talk about that in a little bit because there was an addition to that table about when an arc flash hazard may exist. And it has to do with the interaction side of this. And so the interaction, number 2, that's also equally important. And what I wanted to emphasize is this references when the electrically safe work condition is necessary, not how you establish it. That's later on in NFPA 70E. The Electrical Safety Program. The correlating committee required that references to safety management systems and safety management standards be removed, and they're relocated to the annex, to an annex. And so 110.5A, this text was struck out because it's referencing the Occupational Health and Safety Management System. And also there's an informational note. Informational note 2 directly referenced an Occupational Health and Safety Management System, and that was removed. And so instead, there is a reference, an informational note, to NXP. And NXP is about aligning the implementation of this standard with occupational health and safety management systems. Human error. I think if we could attribute some of the electrical safety issues to one common denominator, I think this is it, human error. And so human error was added previously, but it was clarified a little bit this time around. And by clarification, what I mean is this states that the risk assessment procedure shall address the potential for human error and its negative consequences, and here's what needed clarifying, on people, processes, the work, environment, and equipment. That's a pretty broad statement. But actually remember, NFPA 70E, it's about electrical safety. So a little bit of extra text was added relative to the electrical hazards in the workplace. So this was revised a little bit to focus on the electrical hazards. Another new addition, the electrically safe work policy. It's a new subsection, and it just states that an electrical safety program shall include an electrically safe work condition policy that complies with 110.3. Now, this may seem maybe obvious, but now it's part of NFPA 70E, that if you develop an electrical safety program, that it has to have in there the electrically safe work condition policy. So this is a requirement. Now, again, emphasizing electrically safe, the electrically safe work condition. Additional training and retraining. A bit of a change here, just really an addition, that this used to just simply state retraining. Well, that kind of implied that you're retraining maybe what you already went through. But sometimes it's necessary to just have additional training. Maybe there's something new. It's not that you're retraining, there's additional training. And so those words were added, the additional training and retraining for this. Types of training. Oh, who could have foreseen this? So the types of training, 110.6A4, type of training, there's an informational note that was added. And this informational note says, classroom training can include interactive, electronic, or interactive web-based training components. So this was written before 2020, and it recognizes that electronic training is widely used. I mean, who could have imagined this particular year where people are staying at home, you're not able to get in front of large groups and so forth. And so I think this was a bit ahead of its time. And actually, speaking of being timely, I started the end of last year, our web developers, we actually began an online training platform last year. So the timing couldn't be any better. And so we rolled this out just a couple weeks ago. It's kind of a soft opening. And this program is being recorded. And so the recording will be available to all of you. You'll have access to it, and it'll be out here. Over the weekend, we're going to upload it. It'll be out. You'll receive an email notice about it, and you can go out and use it, review it, share it with your friends and colleagues and so forth. The host and contract employer's responsibility. This was relocated from 110.3 to 110.7, just part of that reorganization shuffle. And this has been around for a while, where the host employer has knowledge of hazards covered by the standard that are related to the contract employer's work. There shall be a documented meeting between the host employer and the contract employer. However, there was a new addition. And the new addition is an informational note. And it states that on multi-employer work sites, more than one employer can be responsible for identifying hazards, conditions, and creating safe work practices. What's this telling us? Simple. This is telling us safety, it's everybody's responsibility. And that's really what this informational note is all about. It's everybody's responsibility. Test instruments and equipment. So with test instruments and equipment, a minor change here, but it actually has, I think, some far-reaching ramifications. The text operating at voltages equal to or greater than 50 volts, that was replaced. And it was replaced with where the electrical hazard exists. And let me show you what this actually looks like, the full text. The reference to 50 volts was eliminated. The reason the reference to 50 volts was eliminated, that kind of implies that the only real issue is the shock hazard. And there's more than a shock hazard. In fact, somebody that I worked with years ago, this was back in the early 90s, he was performing voltage measurements, and it was on a 480 volt system. This facility that he was at was having some low voltage problems. So he was out conducting 480 volt measurements to see what they have. And one of the places that he performed the measurements was at a dry type transformer. He actually took the cover off the dry type transformer, which is certainly not a good idea. And he goes in to measure the 480 volts, see the nominal 480, to see what they actually had. And what he failed to recognize, 480 volts was the secondary side. And he tangled with the primary, which was 4,160 volts. Shock hazard wasn't his only problem. It was a massive arc flash. And due to the burn injury that he sustained from the arc flash, not just the shock that was there, performing voltage measurements, he died. It was about a week later. So yeah, this is to emphasize or put a greater emphasis that there's more than just the shock hazard. And so what the text looks like, only qualified persons shall perform tasks such as testing, troubleshooting, and voltage measuring on electrical equipment where an electrical hazard exists. We have a new section, 110.12, equipment use. Equipment shall be used in accordance with the manufacturer's instructions. So my wife saw this. She sees me writing and reviewing a lot of this stuff. And she saw the equipment shall be used in accordance with the manufacturer's instructions and kind of chuckled. And she just shook her head and said, "Did they write that specifically for you?" And, it's like, what, me? I'm offended. And no, it's the typical thing. I'll be working on a home project and start running into trouble. And then, of course, she says, "Well, did you read the instructions?" No, the instructions are in the trash, or they're in the box. And so, yeah, so this is official. The equipment shall be used in accordance with the manufacturer's instructions. And that is very important when it comes to electrical safety. Establishing an electrically safe work condition. This is the procedure. And so this involves lockout, tagout, and all the steps for the electrically safe work condition. There were a few revisions made here. 120.2b, the lockout, tagout procedure, this text right here has an addition to it now. So the procedure shall be developed on the basis of the existing electrical equipment and system and shall use suitable documentation, including up-to-date drawings and diagrams. I'm going to talk about that one in a moment. However, there's an addition. The procedure shall meet the requirements of applicable codes, standards, and regulations for lockout and tagging of electrical sources. So this was added to make sure that any lockout tagout procedure meets applicable requirements and regulations. But this language about the up-to-date drawings and diagrams, I mean, this is still the age-old question. And I run into this, and I know all of you have run into it, that you're trying to find a diagram so that you know where all the sources of power are coming from, or maybe to even perform a study. That's another use for the diagram. In this case, we're referencing lockout, tagout, though. And if you're able to find a diagram, and sometimes that's even in question, you find out, well, it's not exactly up to date. So this is something that needs to be kept up with, although quite often it gets pushed to the side due to other priorities. Another modification, the lockout device. There was a modification made to align this with OSHA. The lockout device shall be permitted to be only a lock if the lock is readily identifiable as a lockout device, in addition to having a means of identifying the person who installed the lock. And the addition is provided that all the following conditions exist. Only one circuit or piece of equipment's de-energized. The lockout period doesn't extend beyond the work shift. And the employees exposed to the hazards associated with re-energizing the circuit or equipment are familiar with this procedure. And again, this is to align with OSHA requirements. For lockout tagout, there are also requirements about stored energy. There was a new addition that references, for more information on methods and procedures to place capacitors in an electrically safe work condition, it references a new annex and a new article. So Article 360 and Annex R were both added, and those deal directly with capacitor safety. And they're both quite large articles. In fact, one of the things I do is I am one of the contributing editors of Electrical Contractor Magazine, NECA's magazine. And two things that relate to all this. Every 3 years, I write the NFPA 70E changes article. And that article just came out last month, the May 2020 issue. So if you go to the website is ecmag.com, you can find that. But the other thing is my article coming up in the July issue next month is all about Article 360. So you get kind of a heads up for what that's all about. So there's quite a bit coming down the road. This is a new reference to the new Article 360 and Annex R when it comes to releasing stored energy of capacitors. Similarly, the process of establishing and verifying an electrically safe work condition has releasing mechanical energy. And the way this read originally from 2018, release or blocked stored mechanical energy. That's kind of a broad term. Mechanical energy? I mean, that could be a lot of things out there. So this was tightened up a little bit, and the new and improved version of it is block or relief stored non-electrical energy devices that could re-energize electric circuit parts to the extent that the circuit parts could not be accidentally energized by the device. So this is now focusing on the electrical system. There was also a modification made to 120.5, in particular 120.57. So in 2018, there was an addition where one of the methods for verifying the absence of voltage is to use what the industry now refers to as an absence of voltage tester. And I actually have one here. It's not connected or anything, but it looks like this, just to give you an idea of the physical size, and it is right here. And so the absence of voltage tester, the idea is to be able to indicate that there is no voltage so that you don't have to go in and expose yourself to potentially, well, if it's still energized. That was the idea. So there was an addition now, and it was a new informational note that was added that just references the specific standard for the absence of voltage testers, UL 1436. So that's a new addition. Work involving electrical hazards, Article 130. There were a few reorganizations that occurred here just because some of the information in 130 now found its way into 110. So there was a bit of a reorganization here, and that included some of the general requirements. This was reorganized and rewritten a little bit because some of this got moved to Article 110. What was 130.3 is now found in 130.1. And so just a bit of shuffling around here. With this one, when energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts are not put into an electrically safe work condition, and work is performed as permitted in accordance with 110.6, that used to be in 130, all of the following apply. Only qualified persons are permitted to work on the electrical conductors. An energized electrical work permit shall be completed, and the shock risk assessment performed, and the arc flash risk assessment performed. And so this is a lot of the same concepts, although some of this was reworded as part of the reorganization that has occurred. The shock risk assessment. So there was language that is part of the arc flash risk assessment that has now been duplicated, and what that language looks like right here. Estimate the likelihood and severity. The estimate of the likelihood of severity of injury or damage to health and the potential severity of the injury or damage to health shall take into consideration all of the following. Number one, the design of the electrical equipment. Number two, the electrical equipment operating conditions and the condition of maintenance. And so this is really to align it with what we already had in 130.5, because the same type of language exists for the arc flash risk assessment. But let's look at this. So we have item number two, the condition of maintenance of the equipment. Well, okay. I actually took this photograph years ago, and if you were to try to make a judgment about the operating condition or a judgment about the condition of maintenance, I don't know. I don't think that would work out too well. So, you know, there's a lot that goes into this when you're trying to evaluate. Is there a shock hazard? Is there an arc flash hazard? I mean, for the shock hazard, if you look at this close enough, you'll see a few covers removed and things like that. I don't know if it's energized, but you don't know. I do have to give them credit for creative conduit routing. They made a very effective use of flex conduit for this one. Estimate the likelihood of occurrence of an arc flash incident for AC and DC power systems. This is new. This is a new addition. Some people have been talking to me about this, and let me explain what this is about. So we have these tables, and I mentioned the tables. The first sort of version of these tables were introduced in the 2015 edition, and it lists certain tasks, and then it lists, it didn't start out this way, but now it says likelihood of an arc flash, yes or no. And so there's a lot of different tasks in there. And in general, if you have equipment where all the covers are in place, normal operation, and just operating it, it's considered basically not a high likelihood of an arc flash. But there's one in there now that is. And it's the one that was introduced for 2021. And so what this looks like, if you're going to operate a circuit breaker or a switch for the first time after the installation or completion of maintenance in the equipment, the first time operation. Why is that? Well, I don't know if any of you have heard of the smoke theory of electricity. You could do a web search for it. It's actually there. It's kind of a joke, but all things are powered by smoke. So I have worked with people in a past life, back actually in the late 1970s, that they subscribed to the smoke theory of electricity. And their way of checking a circuit is, oh, we did okay. Let's just throw the switch. If we see smoke, then we know we got to go fix something. No. You know, is there a huge likelihood when you energize a breaker? Well, I can't contradict this, but within NFPA 70E, the rationale is yes, the first time you're operating a circuit breaker or a switch, after its installation or after completion of work or maintenance, over on the far right, likelihood of occurrence of an arc flash, yes. That is a new change to the 2021 edition of NFPA 70E. I want to look at incident energy analysis next, because this is going to go into the next few subjects. So the concept of an incident energy analysis is, number one, you calculate or estimate the prospective incident energy, the severity of the arc flash. And then you select PPE and clothing with an arc rating sufficient for the incident energy. simple enough. The incident energy analysis in most parts of the world, if this is performed, is based on IEEE 1584. The second edition of this standard came out in 2018. If you don't have a copy, you can go out to techstreet.com. That's actually the organization that IEEE uses for the delivery of the standards. And you can order your copy of it out there at TechStreet. But IEEE 1584, it has its origins. The 2002 edition is the one that really got things moving. It was a standard based on empirically derived equations. And then we have the 2018 standard. So this is part of the incident energy analysis. And it wouldn't be complete if I didn't have at least one video showing an arc flash. And so this video that you're about to see is an arc flash that I staged. It was part of a pretty big project years ago. It was 50,000 amps of short circuit current, 480 volts. It was a really large switchboard. So let's see what this looks like. I wouldn't want to be standing in front of that, but that's really what the incident energy analysis is all about. It's actually predicting the severity of an arc flash for a given set of variables, and then selecting protective equipment, protective clothing, arc-rated equipment that can protect you from the incident energy from the arc flash. Now, why am I talking about this? Because there were some changes along the way. Some of these changes, there was an informational note that was added. So what we have is there's table 130.5G, and this is actually for selecting PPE when the incident energy analysis method is used. There's a table for selecting PPE, and I'm going to show you kind of an excerpt of it. There were two changes made to that table. Similar changes made to the NFPA PPE category table. So both have this similar kind of a change. And so this first change is if you're wearing arc-rated PPE like this, this is a 65 calorie PPE. So if you're wearing arc-rated PPE and you have the need to wear an outer garment, either for weather to protect you from the elements, or maybe for safety, like a high-vis vest or something like that. What this is designed for, this new informational note, is that you can wear those types of garments as long as they have an arc rating, and the arc rating doesn't have to match what your actual protection requirement is. So the objective is, if there is an arc flash, just to make sure the garment doesn't ignite and keep burning. That's what it's all about. This is actually your primary protection. So there have been a lot of questions about that over the years, and that was a change that was made to the 2021 edition of NFPA 70E. So it actually specifically reads, the arc rating of outer layers worn over arc-rated clothing as protection from the elements or for other safety purposes, and that are not used as part of a layered system shall not be required to be equal to or greater than the estimated incident energy exposure. So that's new. That's one of the additions. Another is about footwear. In the past, it's been permissible to wear leather footwear or dielectric footwear, and that was really all that was mentioned. And now there's an informational note that states footwear other than leather or dielectric shall be permitted. So you can use footwear other than these two types. Permitted to be used, provided, oh, there's a catch. It's been tested to demonstrate no ignition, melting, or dripping at the estimated incident energy exposure. And so that's a new informational note also added to the table for selecting arc-rated clothing and PPE, and also for the PPE category table. Where we have that is right here. This is for the incident energy analysis, 130.5G, and there's a whole lot more than what I'm showing right here. But this table is broken up into the PPE up through 12 calorie per square centimeter, and then at the bottom greater than 12 calorie. And so now for the arc-rated outerwear or high visibility apparel, they used to have the word safety in there, that was removed. Down at the bottom, that's where you're going to find the note about the arc rating of the outer layer worn over the arc-rated clothing as protection from the elements or for other safety purposes, and that are not used as part of a layered system, shall not be required to be equal to or greater than the estimated incident energy exposure. That would have just been difficult. If you're wearing like a 65 calorie system, how do you get a high-vis vest to have that kind of a rating? Then we also have the reference to leather footwear. This is where we now have the ability that you can wear something else if it's been tested to demonstrate no ignition, melting, or dripping at the estimated incident energy exposure. This might look familiar for some of you. If you look closely at the label, we have an incredibly high incident energy. This is an age-old problem. This one, it's over 130 calories a square centimeter. I'm sure many of you have run into this. Normally, what causes such incredibly high levels of incident energy is the arc duration. It's not that the arc would last like forever, but the calculations will sometimes indicate that. And actually, this particular piece of equipment, this is a service switchboard. So the device that's going to, we'll call it limit the arc duration, it was the utility company fuse on the primary side of a transformer. And in that kind of condition, a lot of times if there's an arc flash, the arcing current, that type of device may take until like next Tuesday before it decides to operate. So as a result, you have this really long clearing time. But there's a problem because people will recognize, well, we need to de-energize. We need to establish an electrically safe work condition. Well, that's correct. That's what you need to do. The problem is, in establishing the electrically safe work condition, one of the last steps is you go verify that it's de-energized, electrically safe, the absence of voltage. And until you've verified that there's an absence of voltage, you treat it like it's energized. Well, if you have 130 some calories, what are you going to wear for that? And this has been the age-old problem. And so there is new language within NFPA 70E to address this particular problem. It's the case where you have to wear arc-rated PPE to verify the absence of voltage, but the incident energy is quite high. So there is a new informational note that was added, and it states what we run into, where the estimated incident energy exposure is greater than the arc rating of commercially available arc-rated PPE. Then for the purpose of testing for the absence of voltage, the following examples of risk reduction methods can be used. First off, I want to mention PPE. The arc ratings have been going up considerably. This one on the right, that's actually my hand holding it up. It almost stood up by itself. This is an arc rating of 140 calories. And so arc ratings continue to increase, but not everybody has access to this kind of PPE, and you can still have incident energy levels above these values. So what are the risk reduction methods? Well, you can use a non-contact instrument to check and see if there's a voltage there, or measure on the secondary side of a voltage transformer. Some of us know it as PT, potential transformer, but voltage transformer, before you use a contact test instrument. So you're basically giving kind of a trial run here before you actually make contact. Another method, look for the visible gaps with the conductors. That'd be like a switch. You open, if you have access to actually look at a switch, is the switch open before you use a contact voltmeter. Increase the working distance. Now the working distance is really critical for a lot of this, because the working distance, when someone calculates the incident energy, it's actually based on the distance from the source of the arc flash to the worker's torso and head. And so increasing the working distance, if possible, that may go a long way towards helping out. Another example of risk reduction method, consider different design options. Maybe use some type of current limiting type of a device. And remember, I mentioned IEEE 1814. That's going to be coming in, and that's going to give us some options. Another change to the 2021 edition. We have a table, one table that now is part of a pair of tables. We had table 130.7C7. That was for rubber insulating equipment, the maximum test intervals. That is now 130.7C7B. And we have a new table. That is table A. And table A is for the maximum use voltage for rubber insulated gloves. And what that table looks like, and notice my note down at the bottom, this is just for discussion. You actually need to use the actual table from NFPA 70E when that comes out. But this shows the different classes of gloves and then the voltage ratings. And on the right, the distance between the gauntlet and the cuff, the minimum distance. So that would be like when you have your voltage rated glove and you have your leather protector, the distance from the gauntlet and the cuff. Right in here, there's a certain minimum distance that's required. Usually you far exceed it, but there is a certain minimum distance for that. And then the original table, that's just been given a B designation, 130.7C7B, so that is still there. This was another change. I actually got kind of involved in this one. For PPE, testing and ARC-rated PPE, historically, NFPA 70E has referenced ASTM standards. And the last cycle, all of those standards were moved to a table referenced by an informational note. They were basically taken out of the mandatory part of the text. One of the things that happened during this, I'm an ASTM member, although I'm not as active as I should be. One of the things that happened was at the top level of this ASTM committee, they sent out an email like, oh, great. You know, there was a lot of heartburn over this, moving it out. And there was a statement made about next thing you know, we're going to be using IEC standards. And well, being chairman of all those standards, I had to put on my official IEC hat and fire back. It's like, wait a minute. IEC standards are just as good and maybe even a little more stringent than ASTM standards. But what happened along the way is, guess what? 2021, the IEC standards have made their way into this. You notice 61482-1-1, that's the actual test method. And the one thing that's different between ASTM and IEC is we have what's called ELIM, E-L-I-M. That was to, well, I won't go into the details, but that was to satisfy certain European-specific requirements. And it can be a little bit more stringent than the standard testing. This is actually the standard, one of the standards right here for testing, but it's very similar, maybe slightly more stringent than the ASTM standard. And in fact, the test setup, this is the test setup. This was in Geneva, Switzerland. I was there recently. And if you look at the test setup, and there's a couple labs that'll do this. Big one is actually in Canada. There's a lot of testing there. So this is a calorimeter that measures the energy, and then you have opposing electrodes where you put a trigger wire, and then that initiates the arc flash right there. And then you have the fabric samples of the garments on the panels that are spread equidistant around there. Article 360, I mentioned this a moment ago. Brand new. Capacitors were only referenced a couple of times historically in NFPA 70E, but they are a large source of stored energy and quite a source of a potential hazard. And so there is a new article, it's actually quite large, that is broken up into scope, definitions, and then the stored energy hazard. That's really important. And measures for personal safety, establishing an electrically safe work condition that's specific for capacitors. It's not like what we'll call a traditional electrically safe work condition. There are other considerations that need to be made, and the use of grounding sticks. Annex D, just a couple of final comments about the annexes. Annex D is where you had references to IEEE 1584 as well as a couple of other arc flash calculation methods. A big change with Annex D. So what happened is with the introduction of the new 2018 edition of IEEE 1584, we had to make some changes in the annex because historically Annex D, you could look at your 2018 edition and see this. Annex D had equations from a late 1990s paper. Those were some of the first empirically derived equations for arc flash. And then there were equations for the 2002 edition of IEEE 1584. And then there were some equations from a couple of technical papers about DC arc flash. Well, with the introduction of the 2018 standard, it's a very complex standard. The equations are much more complex, and there are tables of many K values, coefficients that are used. And it's like I said, it's a very complex standard. So the decision was made not to include the equations in Annex D. It was just going to be too overwhelming. Without the guidance and everything that goes with it, basically you'd have to stick the entire 1584 standard in there for the guidance on how to use it. So instead, what we have in Annex D is a lot of information about IEEE 1584, the 2018 standard, stopping just short of including, it'd be pages and pages of tables and equations and everything in there. So that was a pretty big change as far as Annex D. And then there was another change to an annex. Actually, it's an addition. And these are just the high points. There were a lot of other, changes that happened to the whole NFPA 70E standard. But I'm just trying to point out some of the major changes. And this one is Annex F, risk assessment and risk control. So there was a new F.7 that was added when you're working around battery systems. And F.7, it's acknowledging that if you're working around battery systems, there's more than one hazard. There's multiple hazards. And they may be encountered when working on batteries. So you have the shock hazard, of course, possible arc flash hazard, but you also have the chemical hazard, the thermal hazard. And so it's acknowledging that the PPE selection needs to take into account all these hazards. And there's a flow chart to help with this. We also have another informative annex, Informative Annex R. This is a monumental amount of detail about working with capacitors. This has some great information in it. This has a lot of equations, calculations when it comes to determining the stored energy and the blast hazard. There's actually information in there about a blast hazard relying on some earlier equations. So let me just take a couple minutes here and see if I can go through a few of these questions. I do want to offer all of you just a huge thank you before I get into the questions. It's just been my privilege to be able to be here. When I saw how many people signed up for this and how many countries, 18 countries, it was just very humbling for me. So I appreciate it. Let me see what we have here as far as, wow, there's a lot of questions here. Have the ASTM standards been removed or have the IEC? Okay, let me answer. This is a good one. So, have the ASTM standards been removed or have the IEC standards been added? Good question. They're all there together. So, ASTM is still there. And in the US, that's what we use. But there are other parts of the world, and they're represented here online, where the IEC standards are used. So, they're referenced in there as well. Let's see here. Any discussion of arc-rated glove requirements? Actually, a couple years ago, ASTM developed an arc-rated glove standard, and we're actually developing one in IEC as well. And so as far as NFPA 70E, the requirements are either arc-rated gloves, they do exist, or you can still use rubber liners and leather protectors. There was some informal testing with these years ago, one of the main PPE testing people, and showed that you get a pretty high arc rating. It's not an official test, but you get pretty good protection. So right now, NFPA 70E is kind of in both sides of this, arc rated gloves or rubber liners and leather protectors. When will the new 2021 NFPA 70E standard be available? Usually it's in the fall. In fact, something else I want to mention, a lot of you are already aware of it, but within NFPA 70E, there's also a requirement that you do go through refresher training at intervals not to exceed 3 years. And the reason it's 3 years, it's to sync up with the new standard. So that's one of the courses that we'll be rolling out here pretty soon, probably in the next month. It'll be a one-day, just the refresher for the new 2021 and reviewing a lot of the main parts of NFPA 70E. Again, I appreciate everybody joining. So have a great day or evening for some of you, or have a great breakfast for some of you on the other side of the globe. So I appreciate it. Thank you very much.